Hello, good afternoon, everybody. All right, thank you for joining us today. We'll be starting in another 5 minutes or so. Yeah, 3 to 5 more minutes. We're just expecting a few more people to attend. Yeah, to just come trickling in. Yeah, so just sit back, hang tight, and we'll be starting the webinar really soon. All right, yeah, thank you. All right. Good afternoon, everyone. Hello. Hi. All right. Yep. So, good afternoon, everyone. Welcome and thank you for joining us today at our webinar, where we will be talking about the smart industry simplified and how to lead the industry with the right steps. So I hope everyone is keeping safe and sound during this period of time. Yeah, and hopefully our situation in Malaysia and Singapore will both be slowing down in the near future and things will be going up. Right, all right. Yep, so by the way, I am JJ and I will actually be your moderator of the day. And joining us today as the presenter is Mr. Wong Kiet Zi. He is actually one of our technical director here at CADVision Systems and also a certified Smart Industry Readiness Index accessor. Yeah. So for those of you who may not be familiar with the term SIRI, of short for Smart Industry Readiness Index, it is actually an identical framework as Industry Forward as well. So in this webinar, we will be taking a look at the overall Industry 4.0 journey in a bird's eye view. And also we'll be discussing on the solutions mapping out to the framework and how it can actually improve the process throughout the product life cycle and more. All right, yeah, so without taking time, please welcome Kiet. Yeah, yep, hi Kiet.
Hi JJ.
Yep, hi, yeah. So
and
yeah.
Good afternoon, everybody.
Yeah, so
Carry on, JJ.
actually we'll start the session today now. Yeah, forgive me for not showing my webcam. My hair is getting a little bit out of control and my clippers are not here yet. Yeah, so yeah, but I'm not going to take up too much time. Yeah, so I'm just going to hand over the stage over to you. All right.
All right, thanks. And good afternoon, everybody. Everybody calls me Kiet. My name is Kiet Zi. I'm based out of Singapore in the CADVision office in Singapore. And before I begin, let me show my screen. Right, so this is my presentation screen. Okay, so before I begin, allow me to just turn off my camera because I think you'll be focusing on the slides and just listening to my presentation. So as I was just saying, I am tasked with this topic today to speak to you about the Smart Industry Simplified. My role, just a quick introduction, I come from the software industry, about over 30 years of working experience in various industrial sectors, manufacturing, in engineering, product design, in supply chain, and in software IT as well. So been all over the place. And recently, my passion and my interest has been in helping companies transform, working out a roadmap for them, helping them do assessments on, how they plan out their transformation. If companies have intention to move into Industry 4.0 to advance their business in the technology area or in any other aspects, whether it's in organizational structure, management structure, and all that. I've been working with a couple of these companies to help them go through their journey. So today's topic is Smart Industry Simplified. So just to begin, let's ask ourselves, what do we mean by smart industry, right? And I always like to start with the basic principles of smart industry. And of course, as JJ mentioned, I'm an assessor for the Smart Industry Readiness Index. So I'll use the components here to take you through what we mean by smart industry. And of course, this framework, the SIRI framework, is also one that is used by the World Economic Forum. So it is quite standard. It's quite well-rounded and comprehensive. So I hope this is going to be helpful. for those of you who may have come across it for the first time. So when we talk about smart industry, there are 6 design principles in Industry 4.0 that we look out for as indicators of your ability to transform into I 4.0 ready business. So the first one is interoperability, and that refers to how machines, humans, and computer systems can connect and communicate with each other through the network or internet. Right, so interoperability is not just about getting connected, but that 2 different systems understand each other and know what one system is talking and what one system is sending to another system, right? So that's interoperability. Second thing is the virtualization aspect. So it speaks to the products and production processes within a plant, for example, can be virtualized via sensors to compare the real with the simulated model. So this is where the IoT sensors come in, of course, IoT and IIoT, right? There's also the aspects of simulation, AR and VR. All kinds of technologies are being brought in here to enable you to virtualize, say, for example, one product. You have a physical product, you can virtualize that product digitally and track the performance of the product, right? But you can also virtualize an entire plant and track how the entire plant performs. Then you move higher, you can also virtualize an entire business and track how the entire business performs, right? So that's what we mean by virtualization. Thirdly, we talk about decentralization as a key aspect of I 4.0 or a smart industry. And decentralization here refers to cyber physical systems within smart factories can make decisions and optimize parameters independently. So this refers to production lines that are maybe split into multiple subgroups that can make decisions on their own. For example, the quality management system, right? So there is a quality management system that monitors the performance, the output, the yield of every station. Maybe you want to be able to let that QMS make certain decisions and trigger certain rework on its own, or in-process rework, as we call it, right? So that is about decentralization. Of course, the benefit of that is when these subsystems are able to be decentralized and optimize and make their own decisions, they become more effective, and the overall system, the overall plant, the overall manufacturing process then becomes more efficient and more optimized. Okay, next is 4, real-time capabilities. And here we're talking about the ability to generate, publish, and use insights from the collection of real-time data throughout the enterprise. And of course, this is key because only if you have real-time information can you then make meaningful decisions to optimize your operation, right? So that real-time capabilities actually contributes to your ability to decentralize. Real-time capabilities also contribute to your ability to virtualize, for example, right? Then we move on to service orientation. So because of the convergence of all these technologies, we find that businesses are now able to create new businesses or new services that is enabled because of some of these capabilities that you've just acquired. So an example of new services is, say here, being able to print your own spare parts. Or what they call digital warehouse. So you no longer need to order spare parts from your equipment supplier. Your equipment supplier will be the one providing you the design and giving you the printer to print the spare parts that you need as and when you need. So imagine you can cut out all the lead time. And of course, these days with 3D printed parts, actually the cost of printing the part is much lower than ordering the actual spare part because of the inventory carrying costs and all the other costs that is associated with it. So this is actually a new service that an equipment supplier can now provide. Lastly, we look for modularity, or a business's ability to modularize their production systems so that they can respond to changing requirements and enable them to handle large volume production as well as high mix, low volume, or what some people may like to call mass customization, right? And this is happening around the world. A good example is BMW now is able to take your customized requirements for the BMW cars, and they actually customize it within the factory, so it is original. It's not taken to a third party to customize. So all these becomes personalizable. How do you do that? The only way you can achieve that is by being able to respond very quickly with your manufacturing equipment, your manufacturing process, being able to modularize and plug and play. So these are the 6 design principles, as we call it, that we look for in a company's ability to transform into a smart business or smart industry. Okay, so now we look at a smart industry from a different perspective. Let's look at the business process. So I 4.0 touches on all aspects of a company's business operation. It looks at a business through the following key business processes. Okay, we know that in any company, there is, if you are a company that sells products or manufactures product, you have production processes, and then you have the enterprise HQs, if you like, operation that takes care of sales, planning, HR, IT, facilities, that kind of stuff, right? At the enterprise level. And then you've got, the production manager taking care of all the manufacturing side of the business. And together we call this the vertical operation. All right. And what we look for is how integrated this operation is. Secondly, we look at the horizontal integration. By the way, can all of you see my cursor when I point to certain things? Just a quick check. Guys, JJ, just wanted to check, can you guys see my cursor movement?
Yes.
Okay, yeah. All right, thanks. Okay, yeah, so I was referring to this horizontal integration here, right? And here we mean, what we are referring to is, of course, the supply chain. On the supply side, how you deal with your suppliers and your suppliers or your third-party partners, etc. And then on the customer end, we're talking about smart distribution. How do you distribute your products effectively, efficiently? How do you communicate with the customers? How do you get feedback? So this is all the horizontal integration. And along the way, if you notice, whether it is the vertical or the horizontal, what we are looking for here is how is data and information generated and communicated along these lines here. Now, every business must have these 2 things usually, right? But there's a third piece that is very important, that is the product lifecycle piece. Now, of course, if you are manufacturing a product or you design products and all that, then this is very significant in your business. But even if you are a service company, this can also be significant because you're dealing with products and you've got to be able to model certain equipment, certain products, for example. So that refers to this integrated product lifecycle refers to how you handle the design, the manufacturing, the engineering process, and all that, right? And how integrated they are as well. So these 3 large components form one framework, if you like, right? This is one way of looking at your business. And as I mentioned earlier, data is generated and used throughout these 3 main business processes. And what we're looking for is, do you have meaningful data? Are you generating useful information? And are you communicating this useful information correctly along these 3 components of your business? And of course, we've all heard of garbage in, garbage out. So what we want to prevent is, if you digitalize ineffective business processes and you digitalize wrong information, then that doesn't necessarily mean, obviously that's not good. So digitalization, we talk about this digitalization a lot. But here we are zooming into digitalization of the right information, the right data, the right object, if you like, in your company. Next, we look at the bigger picture. So just now what I talked to you is process, which is here, right? That's one way of looking at your business. But your business comprises of technology. And in some cases, technology is a very big part of a business because the investment is very heavy here. And then the third part is actually the organization or the people. And under the people, we look at the structure and we look at the skill sets, etc. So this is a framework of looking at a smart business. And of course, these three pillars here, the process or blocks, I like to call it, process blocks, technology block, and organization block, translate into pillars and subcategories, if you like. So subcategories here may be vertical integration, the horizontal integration, and the integrated product lifecycle that I've mentioned. But very quickly, just so you have an idea, in the technology side, we look at automation, connectivity, and intelligence, these three aspects of your technology. So in other words, you can ask the question, how automated is your shop floor? How connected is your shop floor? And how intelligent is your shop floor? And so you go from shop floor to enterprise to facility, and you repeat these three questions for these three aspects of your business, the shop floor, the enterprise, and the facility, right? And together they form 9 key elements of the technology smartness, if you like. And then at the organization side, we look for, as I mentioned, talent, readiness, and the structure or the governance of the organization. Are there the proper rules, the right policies in place? Do the team workforce, the staff like yourselves, is there a structured way for you to learn and to improve, to develop yourself? Is there a right leadership provided? And does the leadership understand all these different aspects of a smart industry? Because if your leadership doesn't understand, then obviously the people may not know how to follow. All right, so just a very quick overview here to give you an idea of the framework and the context of what we are going to talk about. So now we're going to zoom into the integrated product lifecycle, because the topic today is smart industry simplified, right? So it's very difficult to show how you simplify everything here, because this is a very big part, a very big picture, right? So we're going to take a smaller piece, integrated product lifecycle, and zoom into that to show how we can simplify the processes, how we can simplify the management within this little box here. Okay, so we'll take a closer look at product data management. So let's jump straight in. What is a smart product lifecycle? Well, it's an integrated product cycle of people, processes, and systems along this product lifecycle, and it encompasses these 6 stages here. If you can follow my cursor, all right, these 6 circles here. So traditionally, what I like to call the I 3.0 or I 2.0 scope of a product lifecycle management, you typically just look at design, engineering, and then manufacturing. As a designer, once you've handed your designs over to, say, manufacturing, you pretty much say your job is done, right? You consider your job done. I've handed over to manufacturing. They are now manufacturing it. But not so in Industry 4.0, or not so in a smart industry, right? You need to consider how your customers use your product and how it can be serviced and how it can be disposed. So you then need to track the performance of your product and how your design actually influences the various stages of this cycle. And within the smart industry, how do you judge, what is the grading of smartness, right? And so we have these 6 bands from 0 to 5 of grading to sort of give ourselves an idea of what we mean by smart product lifecycle. So yeah, you need to have that in order to benchmark yourselves, right? Otherwise, everybody can say that, hey, my process is very good, versus the other process. So what we're trying to do here is to, gather a lot of, or the people behind this series has spent a lot of time gathering a lot of data from various industries in terms of how they do their product development, and then come up with certain definitions. So obviously we'll leave 0 because it's undefined, means everything is very ad hoc and chaotic. But defined here would mean that the processes along your product lifecycle are managed and executed in silos, right? These guys in design maybe don't talk so much to engineering, certainly don't talk so much to manufacturing, for example. And they are using, their communication is very minimum based on a set of formally defined instructions, mostly performed by humans with analog tools. And notice here, when we say analog tools, yeah, everybody thinks that it is paper-based, but in today's world, Excel and email is considered analog, right? We're not trying to dispute the definition and all that. It's just that we're trying to reflect the fact that Excel and email is already very widely used, but it doesn't help in the integration of the process as much, right? So it's still considered a lower level form of communication and digital tool. Then you have digital. So digital here would mean, for example, you're in every one of these circles, you are using some digital tools like system, software, etc., to do your work. So in design, you may be using CAD and CAM software to design, like SolidWorks. In engineering, you may be using some other software like simulation, etc. So then we look for how integrated this product lifecycle is, right? And the integration here refers to digital tools and systems that manage the product lifecycle are formally linked with each other. Formally linked actually means that they are able to exchange information with each other along the product lifecycle. However, the trigger is predominantly by humans. So the systems are not like taking proactive action to do certain things. The humans, the engineers themselves are the ones triggering things. So one good example would be you may be using ERP, CRM, and your PDM all linked together. They can sort of send and receive information with each other, but the humans have to start the process to trigger the process. Now, we don't have time to go through all of them. I just want to give you a very high level flavor. After integrated, then you look for the automation, how automated they are. And then finally, you look for how intelligent your product lifecycle is. And by intelligent, we are referring to a couple of things we can look for, right? I'm not sure if any of you are familiar, like you now have software that can do predictive or generative design. That is one level of intelligence because you're no longer relying on traditional methods to design a good product, but you're also using software and certain aspect of AI to actually help you suggest and predict what kind of design would work. The other aspect of it is using digital twins. As I mentioned earlier, you have a physical product that is circulating in the field out there, going through this life cycle. And then you have a digital model that is actually following the performance based on IoT and sensors that are actually gathering data all the time on the particular usage. And we do have examples of companies that manufacture pretty sophisticated equipment. They ship around the world, but they have a control center that monitors all their equipment out in the field based on the IoT that is sending information back to them. And of course, with that kind of information, they can trigger proactive or predictive maintenance. They can do prediction of downtime. They can recommend when is the best downtime, etc. So that is what we mean by ultimately an intelligent product lifecycle. Okay, now we need to ask this question. Why is product data management critical, right? And again, this is just to paint a context of what we mean by a smart industry and how do we simplify, because if you don't understand why it is critical, you may not understand where to simplify things, where to attack first. So I'd like to share with you this diagram. I've always found this a very useful diagram to look at. On the x-axis here, you are looking at all the cost factors related to manufacturing a product, to producing a product in your business. And on your y-axis here, it measures the level of influence or impact each of these cost categories have on the overall business. All right, so I think a picture speaks 1,000 words. What we are showing here is that your product design, although may typically occupy 5% only of your cost, the impact that it has on the success of your business, the overall success of your business, can be very high. And this is based on some real data that is done, from a research firm that actually has been used by many commercial companies. All right. So the point here that I am trying to show, why am I choosing the product data management here to look into, is because your impact is the greatest. And one of the key principles of the Smart Industry Readiness Index is to get any company who is doing this kind of an assessment to first look for where is your greatest impact, to put your dollar in, to put your investment in. So now that we've established that product data management is a critical part and it's a high impact part, we need to now look at what are the risks and that are associated with the product lifecycle. So in other words, another way of looking at it is, where are the typical problems in the product lifecycle that we encounter? I have split this into 4 different categories. First is, or 4 categories of challenges. So the first one is non-standard product development of your process and data. So your product development process has to be standardized, first of all, streamlined, and the data must be streamlined as well. All right. So what is the impact or the problem or symptoms that you come across if you don't have a standardized process and a standardized data, for use? Customers cannot read my product data. That is obvious. Secondly, I can't find the part that my colleague designed, because process is not streamlined. One person does it in one way, another person does it in another way. Or I can't find which other models use this same component. Also very common, which I've come across personally in quite a number of companies. They reinvent the wheel, so to speak, almost on a monthly basis. All right. A lot of file conversion required for product data to be usable in marketing, engineering, and production. So again, if your processes are not streamlined, yes, you are thinking about just designing a product for the purpose of making the product. But you may not consider how best can I portray this product, how best can I market this product, etc. So that same data needs to be used by multiple departments, but along the way, it gets converted from one format to another, for example. And it takes a long time to find the right replacement part. And as a consumer, I certainly have felt the pain of it when you try to look for replacement parts of any household items, whether window handle, that kind of thing. Okay, so that's the first category. The second one is the inability to share and use product data within a company. All right. So first, you have a problem with inconsistent processes or non-streamlined processes and data. Second, you now want to figure out how to share this data and how to manage this data within the company. And on my left panel here, what I'm trying to show is an example, although it's for consumer product. Some research data of that says that more than 1,000 new SKUs are being created per year per brand. All right, so that's a lot. 700 attributes managed today per SKU. For each of your SKU, you've got 700 categories, or not categories, fields, attributes that you've got to use to describe what this product is all about. And then 500 formats to support retail partners globally, especially if you're in consumer business. And then it takes an average of 4 weeks to prepare the attributes for a new SKU, simply to be updated into your database, into your product catalogs, etc. And then lastly, there are 3 to 5 people on average per market dedicated to aggregating product data. So a lot of manual work is involved to manage your product data. All right, so this is one aspect from an industry standpoint. From a company standpoint, you may encounter some of these symptoms. My procurement specialist cannot see the latest bill of material from the design team, and they might buy the wrong part. That's always the fear, and it does happen. And I've certainly seen companies throwing away or writing off couple of $100,000 US just because somebody sent the wrong design. Secondly, I can't find the part that my ex-colleague designed in his computer. Again, a symptom of non-standardized process, and certainly a symptom of maybe inconsistent use of tools, and resulting in things being stored all over the place. Which model is the component being used? Same thing in the previous category. The same symptom will arise here. Not being able to find your part. Imagine if you're having to deal with thousands and thousands of SKUs, you may not be able to easily find the same part. My EE department or colleague can only read step files. I have to keep converting them. So for those of you who are doing CAD design and all that, I'm sure you know what I'm talking about. There's always challenges on communicating between the electrical team and the mechanical team. And then my colleague sent me the wrong version of this part. Again, as I said, this is a result of not managing the right processes and managing the data consistently within your company. All right. And lastly, I lost the email that contained the latest design my colleague sent me. And I know it sounds quite primitive, but I certainly come across it very often, even these days, when people communicate design information via email, which is, as I mentioned earlier if you remember my product life cycle, I mentioned earlier that in band 1, you have defined your processes and all that, but digital tools like Excel and email is considered analog, not digital, right? This is the reason. Third category, inability to share and use product data within your ecosystem partners. This is just an example, if you were to try and model out how one company exchanges data, whether it's your design data, your parts data, your and usage data, performance data, etc. It's quite messy if you are all not using a interoperable system. If you can recall my very first slide, one of the design principles is interoperable. So this is an example of it. And what are the symptoms that you might come across? I have to convert my design so that customer can read them. And that's quite often what I hear as well. I have to pay more for my equipment because they need to customize their system to read and use my designs. Also quite common, especially for equipment manufacturers that use proprietary control systems, for example. And these days, if you buy new equipment and you say that I want to be able to open and read this equipment's data, especially the performance data and all that, they do charge you if their system is proprietary. We had to remanufacture this part because we read the design data wrongly. So again, as a result of, especially if you outsource your manufacturing, everybody needs to be careful with that, obviously. But if you do outsource your manufacturing, this is a very important step. How do you make sure that your data, your design data, your manufacturing data is sent and read correctly? And then the standards body cannot recognize my design files, and as a result, my certification is delayed. Come across that as well. My files were too big to send via email. So some of these are very typical. I'm sure most of you have come across this or have heard in one form or another. Lastly is concerning security, right? The last category of risk and challenges. Just to give you some example, statistics here, the number one cause of data breaches is data theft. There are about $386 billion estimated spent on securing PCs and systems, within a period of 5 years from 2015 to 2020. And 91% of attacks on companies in the manufacturing industry came from outsiders. So of course, it's I believe everybody would have heard in the news lately as well. There's been a lot of attack, a lot of hacking, a lot of ransomwares, and large multinationals are forced to close down because of these security issues. So especially when it comes to dealing with IP, intellectual property, you will come across these challenges like especially as a contract manufacturer. You want to manufacture the product for these customers, you want to bid for the project, but just to get their design data, the customer may require you to have certain systems and certain security. And in some cases, of course, even the customers will charge you a small fee to set you up so that you can have access in a secure environment to some of their data. My equipment supplier charges me, as I mentioned earlier, for proprietary data because, again, they want that security, right? They want full control. My server was hacked. Some of my designs were corrupted, and I have to redesign. Unfortunately, it does happen. And my ex-colleagues stole my designs, So I know I'm taking from my own experience, talking with various companies. These things do happen. And all these things can be avoided if we do think about it, if we do think about how we do our integrated product lifecycle, how we manage it properly. So with that context in mind now, with that idea and understanding of what are some of these challenges, I just want to now go into the positive side, the solutioning side. What can we do, right? So how do you adopt an integrated product lifecycle? Now, again, it's also still a fairly big topic. So I just want to highlight a few keywords here, just to give you an idea and a flavor of what an integrated, a smart product lifecycle would reflect, right? First of all, you would look for digitalization and integration, as I've already pointed out, right? So look for aspects that you can digitalize and integrate. Look for connectivity. Look for traceability, especially if you're designing products that require certification like ISO 13485. You need to have that traceability and auditability. And then look for flexibility in your system. How flexible is your product lifecycle, and how much error gets generated in your product lifecycle? So this is just to get you started to think about the aspects or attributes of a smart product lifecycle. The other aspect is, how does your product data management interact with other functions? Let's say this is your product data management system. How does it interact with sales, marketing, engineering, manufacturing, and your logistics people, right? With that in mind, I would like to show you what we like to think of as a streamlined process of integrating the product lifecycle all the way to, in this case, manufacturing. Right? I can't show the entire cycle from design all the way to use and disposal as I showed you in the circles just now. But this is an example taken from a real company in the precision engineering industry. As most of you probably will know, look at it, this is a swim lane. On the very left, you have the customers, and then next to it is the engineering team, the engineering department. If you are from the precision engineering industry, I guess I hope this is familiar enough to you. Then there's sales, which uses ERP. Then there's production using MES, right? So the start of the process is customer sends you an RFQ, and then the engineering team receives it. Well, typically it's the salespeople that receives it, right? But it gets passed to the engineering team. They look at the design and they say, how can we manufacture this? Do we have the right equipment? Do we have the right tools to manufacture this? If yes, they come up with a preliminary manufacturing method, and then they give a quotation based on the estimates. So quotation is received by the customer. They look at it, they like it, they create an order, they issue an order to the sales team. Sales then says, great, I now have the order, let me pass it to the engineering team again. Now you can start working on the design details. When I say the design or engineering details, in this case, because it's precision engineering, so you're typically looking at how you cut a part. And what are the steps, what are the operations I need, what are the tools I need to fabricate this part. So at this point, the engineering team, let's say they have done the design, the detailed engineering process. Now they pass it to the material planning for them to buy the raw material they need, for example. And then the sales team will issue a production order to the manufacturing site to say, hey, you can start planning for the manufacturing of this part. So then the manufacturing will do the planning. Okay, so at this point, the work order is received by the production already. There may be a delay, right? Doesn't mean that the production will start immediately. There may be a delay. But so now we go to the next slide. Now, when let's say the production team is ready to start production, they then have to trigger a signal and say, hey, I'm ready to run. Is your engineering design and engineering steps or operations, are all this information, this data still current? Can you send me the latest approved design? So again, they pull from the a PDM in this case into the manufacturing execution system to do the pre-production setup based on the latest engineering data, right? Then they do a production check. This swim lane here, it refers to the integrated systems, which is like your software hardware that controls, or what I like to call the control systems that actually control the equipment, right? So the control systems like SCADA and all that will be the ones actually doing the checking. So all this is done by systems, by equipment and all that, not by people. So the production check is done, equipment status is read, production can start. Again, the signal, the control system will send a signal, operate the equipment will start running, raw material will be fed to it, and then the equipment status will be continuously monitored by the control system. And so the manufacturing process continues until it ends. By the time the production ends, then a final production report will then get generated by the MES and actually get sent to the engineering team to look at the production efficiency analysis. And then at the same time, the MES will trigger the ERP to do shipping and invoicing. So what I'm trying to show here is still a very high level picture, but the use of various systems will enable you to manage these processes in a much more streamlined manner. But of course, in the first place, you've got to figure out how to streamline all these processes, as what we have shown here in the precision engineering business. Okay, so I hope this gives you a very quick example of what we mean by simplifying. I know that from an operation standpoint, there are a lot of details that we need to go into, which we don't have time to go into now. But just to highlight a few aspects, as we go through these swim lanes here, what I've just covered assumes a couple of things. One is that there is security between your systems here that are talking to each other. Two is that they understand each other, as I've mentioned before, right? And bear in mind, your production can be in a very different location. One can be in Malaysia, the other one, or one in KL, another one in Penang, another one in Singapore. And so, and your enterprise, your HQ may be in KL, for example, right? And all these systems must be able to talk to each other seamlessly in a secure manner, right? And then because all these things, as I've mentioned, are being done largely by systems, in other words, automated, right? You are able to get all the traceability data, all the audit data for your production, right? So all these things are streamlined. Key attributes, as I mentioned earlier, flexibility, digitalization, are all these things digitalized and integrated? I'm hoping that just a very brief description here shows you the key aspects of it. All right, but just to give you a quick summary, if you are able to implement some of these characteristics or attributes within your product lifecycle or your product data management system, then basically what you look for and what you should try to get is, the ability to search for tools. So like I mentioned earlier, I don't know where this same part is being used in different models. Well, if you have a powerful search tool, it can happen within seconds, and it can prevent you from having to redesign this thing. Automated workflow, like as I've shown in the swim lanes earlier, controls all these things in terms of approval of your engineering design, approval of your final production design, etc. And then change order and all that, of course, is built into it, or your NPI, all those things. Easily add more users, again, scalability, this part here in your system, and compliance, traceability, as I mentioned earlier. If you have a platform that helps you to do all these things, right? Then you have secure data. I do come across companies that actually say, as a vendor, as a contract manufacturer, they say, use my system, my platform to exchange IP, because they're dealing with customers that don't have that kind of security. And in those cases, the customers actually have a much better, much higher degree of trust with this particular vendor, because they have a very secure system to protect their IP. And all this secure data can actually be done in the cloud as well. So your customer doesn't need to install special software and all that. They can actually access data from the web. And as I said, you can have multiple locations and automatic version control so that you don't send the wrong data and all. So with this PDM system, let's go back to what I said earlier, right? This what I showed you in terms of the grading of how intelligent is your product lifecycle. Well, generally, according to the definition, and quite conservatively, I would say that you are able to then achieve Band 3, integrated, where your digitized product lifecycle processes and systems are securely integrated across all stages of your product lifecycle. All right, so I hope this gives you a good idea of what we mean by simplifying and what to look for when you try to simplify a product data management. Next, I actually want to try and show you a short video that gives you an understanding, how to, lets you visualize how these systems communicate with each other. I can't show it to you from my slides here, so I'm going to hand over the video to my colleague Hakimi, who will play the video right now. Over to you, Hakimi.
To an overview, discussion, and welcome to an overview, discussion, and demonstration of the Enterprise IQ SolidWorks add-in from IQMS. This tool provides links from parts designed within SolidWorks and assembly data to IQMS, including inventory, bills of material, project manager, preventative maintenance, and engineering change orders. This makes for a cohesive interchange of data that reduces the potential for manual keying errors and ensures accuracy throughout the system, as well as strengthening the already seamless link between product design and manufacturing. We will now take a look at SolidWorks and the add-in. With this tool, users have the ability to open files from IQMS directly within the SolidWorks interface. When a document is opened, its corresponding bill of material is shown on the right side of the screen. In this case, a multi-level BOM. Below the BOM structure of this assembly, we can see the various areas of IQMS to which this specific item is linked, including inventory, a bill of material, and a project. Once a user has done their work, created and extracted their bill of material, they can import the information directly into IQMS. We can now jump to the bill of material and find the item that was just created in the system. Because the records in SolidWorks and their counterparts within IQMS must remain updated at all times, the SolidWorks add-in provides an update wizard, which ensures this consistency is maintained between the two applications. Users can use this tool to instantly update the IQMS record based on the changes made to the assembly in SolidWorks. As we have seen, the SolidWorks add-in provides the best way to effortlessly integrate vital information with the various modules within IQMS and ensuring vital design and engineering documents are continually kept up to date with the use of document control.
All right. Can everybody hear me? So,
Yep.
okay, great. So after that video, what I hope you can see just very briefly is what we're trying to show here, the interaction between two systems, SolidWorks. As I understand, I think many of you are CAD users and probably SolidWorks users. You can imagine within your SolidWorks environment, your design data, your bill of material is immediately available to your ERP and your MES. So just now that the video was playing, your IQMS or what we call Delmia Works actually, that is actually a combination of an ERP and an MES system combined together. So can you imagine these systems talking to each other seamlessly in a secure manner? Both systems understand each other, the data coming through from one system to another. So all this relates back to, say, interoperability that I was talking to you about earlier, and real time. Because when SolidWorks, when you design something in SolidWorks and you have linked your SolidWorks system to the Delmia Works or IQMS, right? Then your design data is actually almost real time, immediately available to the MES system, right? So I hope this gives you a very high level overview and being able to visualize for yourself what having some of these systems entail, how you can get to that point. Hopefully my explanation has been clear enough in terms of some of the attributes of a smart product lifecycle that you can look out for and design towards that particular direction. Now, let me just quickly summarize. I've just got 2 more slides to show you to tie everything together and to explain why smart, we're all talking about smart industry and all that. What's the whole purpose of having this smartness in your business? Ultimately, we want this smartness because we want to have an agile company. All right, this is what it boils down to. What do we mean by an agile company? An agile company is one that is able to implement changes in the company in real time, including fundamental or systemic changes on the company's business model, for example, right? So what we mean here, a lot of definition, a lot of words here, but actually, put simply, it means that if in today's environment, especially today's environment with COVID and everything, when some event happens, your business has to respond. How quickly your business is able to respond determines how successful you are, right? So that's what we mean by agility. We want to look for that agility. Now, if an event happens here, first the x-axis is time, right? And the y-axis shows the benefits or the value of adaptation, or the value of how quickly you respond, right? So if you respond very quickly, that means in a short time, the value of your response is high. But if you take too long to respond, then the value of your response may be lower. All right. So as time passes and as you react to the event, say a machine failed in the field, your equipment broke down, and you have to respond. Customer calls you, their production line has stopped. Now, you then need to typically go through this cycle of activities, right? You need to gather the data, then you need to analyze what went wrong, and then you need to figure out a corrective action, and then implement the corrective action. As you go through this, time passes, and the value of your response is get decreased. All right. So yeah, so the value is supposed to, you want to try and push the value up, right? So imagine if you have a smart business, a smart industry. As an example, the product data management side, you have all the information ready. You've got your digital twin, or you've got, as I mentioned earlier, you're able to monitor, some of these companies are able to monitor the performance of a machine in the field. So their ability to respond is very, very quick, right? So what you're striving for is shortening the latency, what we call the latency here, of all these activities that you've got to do, so that your time is reduced and the value of your response, by the time you propose a corrective action, your value is high, as compared to just now that graph where your value is low. All right, so what gives you the ability to respond quickly, to be agile, to be adaptive? These are, of course, some of the technology drivers that allow you to do that. And what I've just shown you is the integrated product data management as an example, but there are many other aspects that you can look into. Okay, so with that, I thank you. This is the end of my presentation, and I hope that this has been helpful and insightful to you in your work and your business. Thank you very much.
All right. Yeah. Thank you so much, Kiet, for the wonderful sharing session. Yep. I hope everyone here has actually gotten a hang of how Industry 4.0 and our solutions actually can go hand in hand. Yep. So before we head over to the Q&A portion of things, right? Yeah, I just wanted to let you guys all know, and actually would just like to request for your help or your assistance to actually provide us with some feedback via a quick survey after the end of this webinar session. All right. Yeah. So after this, a pop-up will actually appear after this session, and if you fill that up, we will actually be providing you with a free assessment guidebook that you can use, and it can help you to pinpoint areas and also to scale up your company and department's Industry 4.0 journey. All right. Yeah. So yeah. So just wanted to let you know about that. All right. Yeah. And today we actually do have a few questions from the floor. All right, and of course, if you have any other additional questions, please feel free to put it into the question pane. All right, but yeah, now let's actually get into the Q&A portion. All right. Yes. So the first question that we have here is actually in regards to, I believe we might have already touched a little bit on this. It is actually in regards to security. Yeah. So here we have a question that says, how would Industry 4.0 cyber physical systems deal with the growing cyber threat actors on external and internal supply chains?
Okay. So first, we need to define cyber physical systems. So actually, this is a terminology used within the framework. Cyber physical systems typically just refer to both your IT systems, your software systems, as well as your hardware systems. So that's a very good question, actually. Yeah, cybersecurity is a very big topic these days. How do we secure them? There are many ways. Of course, I don't think we can get into specific solutions or technology here. But the key that if you want to think about how can I set up a smart system and yet secure, then obviously you've got to look at the components that you're trying to secure, right? So IT systems typically tend to have ready solutions for cybersecurity to secure your information systems. Right, so that can be anything from backups to antiviruses, anti-hacking systems, professional ones that you can actually buy, to some very basic stuff that you can do, of course, right? One way to look at it, actually, for some companies that I know, actually take the shortcut, I call it. And the shortcut is to migrate to a secure cloud service provider. All right. So once you migrate to a secure cloud service provider, and I do believe we do have engineers and consultants ready with products as well in this area. One of them is 3D Experience. So you can go on platforms like this where security is actually outsourced to some third party, right? And they can help you do the securing. Now, but the other aspect of it is your hardware, and that's a little bit more tricky. It really depends on the kind of hardware that you use, especially if you have IoT and all that need to communicate over the web. So on those areas, my recommendation is always to work with a consultant or work with an expert in this area. There are ready solutions for securing your hardware systems as well. It may, in some cases, tie to the facility management systems or building management systems. Because don't forget, these days, for example, the meat plant that we hear about in the US, right? Some of their systems involve managing the facility. And once they can get into your facility, they take control. So these are some of the aspects that we've got to look into. As far as actual solution is concerned, I would recommend that you work with a cybersecurity consultant.
Yep, understand. All right. Yep. Thank you for the answer. Yeah, we have another question here, which is any incorporation of blockchain aspects within I 4.0 dealing with smart contracts on assets within supply chain?
Okay, within the I 4.0 framework, right? If you notice, the framework in the international community, they are more concerned about the manufacturing aspect, not the intellectual property, as you might call it, using blockchain and all that, right? Not that particular aspect. Okay, but if you want to incorporate blockchain technology, certainly I don't think that is impossible, or rather, I don't think it is irrelevant in a sense that you can quite easily with technology these days incorporate blockchain technologies to your say enterprise level systems. Blockchain, of course, as we know, typically looks into security of primarily intellectual property or any sensitive data, right, that you want to secure and you want to preserve your IP, where you want to preserve some of your own technologies, right? So in some cases, I've seen companies adopt blockchain within their integrated product lifecycle, particularly when they want to deal with external parties. One example is, I forget the name now, but there is a platform where designers actually share some of their information. And the mode of sharing is actually governed by blockchain, right? Why so? Because obviously they want to protect IP lah. And when they share to certain individuals or certain parties. They are directing their sharing to certain people. So blockchain actually provides a very good platform for them to achieve that. But it's from my own experience, and I must say it's quite limited. It is not that widely applied to individual companies or within say even a multinational company using blockchain to govern how they do product lifecycle management.
Okay, all right, yeah, thank you, Kiet. Yeah, yeah, there are a few questions in regards to the product lifecycle itself. Speaking of product lifecycle management, right? Yeah, so we actually do have a question in regards to that, where some of our audiences today are actually introduced to PLM with PDM. Yeah, so
sorry, PLM and what?
PDM.
Okay.
And PDM, yeah, together with PDM itself. Yeah, so okay. In which cases will they require to use PLM instead of PDM?
I see. Okay. Yeah, it's a question that gets asked pretty often. I think it's to a certain degree, I think it's an issue with semantics lah. But yeah, broadly speaking, PLM, product lifecycle management, is a much broader scope as compared to product data management. But then again, these days the two terms are being used interchangeably. PLM traditionally refers to the entire cycle. So if you can recall my 6 circles, the integrated product lifecycle, where it stretches from design to engineering to manufacturing to customer use to servicing and then disposal, right? So a PLM would actually look at the entire cycle.
Yes. Yes.
Right. And a PLM would actually look into or track, for example, maintenance records. It tracks complaints or issues that are reported for that particular system. So a PLM generally has a broader scope. A PDM traditionally covers the first three circles, from design to engineering to manufacturing. All right, that's what a PDM used to do. But in today's world, as one good example would be 3D Experience platform. In the 3D Experience platform, it actually has the whole thing. It covers the entire PLM scope, right? So yet sometimes, you know, when people talk about it, they still refer to it as product data management very generically lah. But so I guess it depends on which perspective you're coming from, which industry you're coming from. But I would say at this point, think about your product lifecycle journey, and if you are trying to transform your product lifecycle to encompass, or for example, if your first step is you want to say, hey, I want to integrate my product design, my R&D with my engineering and manufacturing, then obviously, you know, you can limit your scope to PDM, product data management. But if you're saying that, no, in today's world, I really need to be ready, I need to track my product in the field, etc., and all that, then what you are actually talking about is PLM. However, what tools you use, don't limit yourself to some tools that are calling themselves PDM, some tools that are calling themselves PLM. Actually, the tools have equal capabilities, very similar capabilities.
Okay, understood. Yeah, but just a quick summary would be PLM encompasses the entire life cycle instead, and PDM in this case, but it's still being generalized as PLM in some sense.
Yes.
Right. All right. Yeah. Okay.
Yes.
Yeah. So yeah, we do have let's address this question in regards to PDM. I think this one we are actually getting a little bit in depth to the details of it. So speaking of PDM, yeah. So does the integrated and automation deal with the ECR or the ECO process autonomously, and also like the part number management is it already been dealt with the issue of parts commonality for BOM family tree problems? Is it already been solved?
Has it been already
using
addressed?
a PDM? Yeah, is it being addressed by a PDM system in place in this case? Yeah.
Okay, so generally speaking, if you implement a PDM, yes, then the broad assumption I would have to make is that then, you know, I would say, I put it this way, minimum expectation that I would have if you say you have already implemented a PDM is that you would have automated your ECN, ECO processes. And yes, you would have automated your part numbering systems. And yes, you should have also automated some form of bill of material management as well. So in general, I guess the answer is yes. But the devil is in the detail. So it is really when you do implement some of these systems, whether or not you consider these aspects as part of your scope. But
understand.
By and large, the tool definitely is capable of handling all these things.
Yep, understand. Yep. All right. Yeah. Thanks for answering that. Yeah. We are running a little bit behind time right now, so I'm just going to try to get everyone's questions answered. All right. Yeah. There is one question here which is in regards to traceability. All right. Yeah. So how can traceability help companies to develop in terms of Industry 4.0?
Okay, can I get a clarification on this question? Traceability can mean a few things. Traceability can refer to auditability, where it is you're tracing it for the purpose of getting certification. Or traceability can refer to the entire cycle from design to manufacturing, where obviously you want to have, like when there is a quality issue that's being reported, then you want to have traceability to say which batch and which particular unit, which time, which station was it manufactured in and all that, and you want to try and get to the root cause, right? So is there a particular aspect of traceability that our audience is trying to understand?
Okay, yeah, perhaps what we can do is we can just try to summarize traceability in that sense, like what you've mentioned earlier,
okay,
where it
maybe
is actually
Okay, sorry. Can you repeat the first part of the question? What is it about
Yeah,
traceability?
sure. Yeah, so how can traceability actually help a company to develop in terms of Industry 4.0? There are also there is some feedback from the attendees. Yeah, traceability also has implication for parallel importation.
Parallel what? Sorry, parallel import.
Parallel import.
I see. I see. I guess you want to have traceability. That's traceability in your supply chain. So I guess, it's a very broad topic here. Does traceability have any impact on I 4.0? Within I 4.0, traceability is definitely one aspect, one key aspect of or attribute of an I 4.0 company or a smart industry, smart business. So what is the impact here, and or maybe I'm trying to understand the application of it lah. In the impact of traceability, obviously in the first part that I mentioned is for certification. That's very critical, right? So that for auditing and all that, to know how you design and what processes you go through for designing, and especially of course in medical and aerospace and automotive, you need traceability for all your design parts and all your manufactured parts and all that. So that's one aspect of it, and it's very high impact. It plays a very key role in I 4.0. The other aspect, as I was trying to mention, in terms of tracing root cause and all that, I think our participant may be thinking in terms of the broad traceability of the entire chain. So traceability in supply chain is actually one big topic, right? Because when you consider parallel import and all that, then you've got to consider customs, you've got to consider the transits and all that, where deviations might take place, let's call it that. Things may get swapped and all that. So there is a very big topic, obviously, with import-export security issues, compliance issues with government policies, mandates and all that. Things like you cannot import things from certain countries that are embargoed. So yes, you do have to take into consideration all these things. What I'm trying to get into, I mean, my topic today is to cover product data management and the traceability within product data management. But if you are thinking about traceability in the broader aspect, Industry 4.0 framework, right, doesn't specifically look at traceability as a single item or element. It looks at traceability within the entire framework. So it shows up in automation of your shop floor. It shows up in the intelligence of your facility management. It shows up in the automation of your enterprise, because how you process your sales, how you process your planning and all that, all have traceability aspects built into it. So I hope that answers the question. I hope that addresses what the attendee is asking.
Okay. Yeah. Thank you so much, Kiet. Okay. I think we have. We'll just do one last question actually, and this is in regards to the agile, right? Yep. So this one last question. Yep, the agile company. Yeah. So is agile from software development industry practically applicable to manufacturing, even in an Industry 4.0 environment, and especially for unpredictability of overseas external supply chains? How much is agile company applicable for Industry 4.0?
I would say very, very related, very, very relevant. So as I said, the agile company is actually one of the end result or desired outcome of Industry 4.0 is to create that agility. I'm not sure if I heard the question correctly, but I think the attendee is asking about software agility, is it?
Is agile from software development industry practically applicable to manufacturing?
Oh, agile from software industry, applicable to the manufacturing industry. I see. Well, aspects of it will be applicable, obviously. But what I am referring to in terms of agility that I showed you in my last slide is really the overall agility of the company. So if you are a software development company, then yes, obviously that is a big part of it. But if you, when we are talking about I 4.0, as I said, the scope of I 4.0 in the original definition from Germany and the international community is that it limits itself to look into purely companies with a manufacturing operation. All right, that's very important to keep in mind. So if your company has a manufacturing operation, then yes, you want to embrace certain elements of I 4.0, as I've shown you in my framework earlier, so that you can achieve the agility overall. So we're not measuring the agility from any single perspective, but we're saying overall, how quickly can your company respond to an external event? So COVID was a very good test for everybody. Certain companies could respond very quickly, and certain companies were stuck. Right? So those that can respond very quickly, very likely did not just implement one part of a system to get that agility. They would most likely have had a lot of other things in place. So what do I mean by a lot of other things? So they would have probably implemented quite a lot of automation in their manufacturing. They would probably have implemented a digitalized smart product lifecycle management system where they can manage their data and all that, as I mentioned earlier. So they may have implemented quite a lot of things, or in their ERP systems, they have made attempts or effort to integrate their ERP with their MES, for example, right? And that's what actually gives them the agility. They may even have thought about flexibility in their supply chain system. So being able to move from one vendor to another very quickly is a very traditional supply chain problem that has been there before I 4.0 was defined, right? So as a supply chain practitioner last time, I would not be able to, I cannot say that I have or rather I need to try and minimize my sole source, my sole source item. So my sole source items are the most critical ones, right? Because it's sole source. If this company, collapses or whatever happens, I'm done. I'm stuck. I don't have my raw material and I can't do my manufacturing. So there are various aspects of agility that a company needs to look at. And that's the reason why within the framework, we look at the integration of the product lifecycle, the integration of your vertical operation, and the integration of your horizontal operation, if you can recall the diagram that I showed earlier.
Okay. All right. Thank you so much, Kiet. And that would conclude our Q&A session for today. So if any of you actually do have other questions, you can actually just feel free to email us at info@cadvision.com.my for Malaysia, or info@cadvision.com.sg for Singapore. All right, and we'll try to get back in terms of your inquiries and your questions from there. All right. And with that, I would like to conclude today's session. Just another quick reminder, we do have a survey form that is available. All right, and we will also be providing the free assessment guidebook to help you pinpoint and to help you guide you along the way of your Industry 4.0. So with that, I thank you guys once again for joining our webinar today. And I hope everyone is staying safe and in good health. Thank you so much, Kiet,
thank you, everybody.
Thank you.
No, thank you.
All right.
All
All right. See you.
Bye.
Bye.